Hello to all. So today we are going to demonstrate parametric studies to infer the response of G+2 building with respect to different seismic zone and soil type. As we know, in designing, we generally design the structure with seismic loading, and in seismic loading we generally take care of all the four zones and also the soil type. So today I have made a G+2 building. I will be demonstrating the G+2 building and I will comparing that building with different zones and with different soil type. So let's start with our concept. We'll open STAAD Pro. So now our STAAD is opened up, and firstly we need to create a new file. Let's suppose this would be a demo video, demo demonstration. So I will name it as a demo one, and then I need to select the particular units. As we are familiar with metric, we mostly create the metric units, and then we need to tap on the create part. To analyze that part, we firstly need to go to the structure wizard, and in structure wizard, now basically why we are going to structure wizard, we need to make a G+2 building. So I'm taking the structure wizard help, so we will easily make a G+2 building by adding some values here. So I'll select frame part, and for frame, before going to bay frame, I'll mention you the same. You need to check the units here too, like these units are in feet and inches, so you need to make sure that the units will be in meters. After applying OK, go to bay frame. You can take any value you want. I'll take the value 20 and approximate 10.5, and width same 20 meters, and the number of bays along the length can be 4 and the height can be 3 because G+2 building, and number of bays along the width would be 4. And after applying, we need to dump this same model in the STAAD Pro window, main window, and as you see we are having an option locate the structure with the different eccentricity. So but for the timing I'm clicking on OK, and I want to my structure to be open from the origin will start from 0 0 0, and here it's our structure. We can see it's very simple to build it with structure wizard. Now I need to define material. So while defining material, you need to make sure that you need to create a material first, and you need to select material accordingly, because I'm doing this for an RC building. So I'll select an concrete material here, and you can even give a particular name to it. Let's suppose I'm giving AM25, and as we know with the formula 5000 root FCK, the value comes how it to be 2.5 into 10 raised to power 7, and with here uh, even the density of concrete, we are knowing that it's 25 kilonewton per meter cube, and the third value we need to change is the compressive strength, that is around 25,000 kilonewton per meter square. After applying OK, uh, you just need to go to the property section, and you need to define a new property. Basically in property you're defining the sections. You're defining sections for your beams and column. So let me define the same for column, and it would be approx 0.3048, around 12 feet. And here make sure, as you have defined the material, you need to select that material and see the material is automatically available here, and then you need to add this material. And if you see in your right window, you'll be figuring out that there is a section that you have defined, uh, now you have to define the section for your beam. So I'll go for 9 by 12.229 meter, and I'll add this section again, and then I go to close the section. Now to apply the section to the particular model, and we'll go to select, and we'll go to this option, parallel to Y. See, if I select this option, all the elements parallel to Y will get selected by this, and then I'll assign the selected beams by clicking on assign. Once I do, and we can see that these all sections which are parallel to y-axis has been assigned by the particular 12 by 12 section. Then I move to other rest sections. As I've selected y, parallel to y, these are the sections which we have already assigned. Now we need to select other sections. So there is an option of inverse. By clicking this, we can get the rest other beams which we want to define, and make sure that this assigned to selected beams should be there to the particular beams, and then you need to click on assign. Once this work done, now you can say that your complete structure has been assigned with a particular dimension. Now further you need to move to supports. So for the supports, you first need to create a support, and to create a supports, let us give a fixed support here. And to apply this support, you need to go on view. It's an easy method. Go to the front view and select the bottom nodes, and assign to the selected nodes, and then assign the same. And see, you can see this in 3D mode that all the nodes has been assigned with the fixed support. Now let's come to the loading part. We have done with the specification, we have done with the material, we've done with the properties now, and even with the supports. Now let's move to the loading part. So while defining loading, to define loading, first we need to define the seismic definitions. Make sure always start with seismic loading, and for the seismic parameters you need to select IS 1893 part 1 2016, and you need to click on generate. Now there are different options. It's up to you. You can choose according to city and according to the zone. We'll go for the zone, and zone, the zones has been categorized according to the city only, and the zones are start from second, third, fourth, fifth, and there are 4 zones, and I'm starting with second zone. And as it's an RC building, so I'll go for the RC building with special moment resisting frame, and all important factor, I'll take this building as an important building. So our value changes here. Make sure take accordingly what's your particular need of the building, and considering the soil type, hard soil, structure type RCMRF, and then after completing this whole, I'm generating. So once you click on generate, you need to add this part. See, you need to add, and yeah, it's done. Then you need to tap on close. Now further go on this the definition and add, and here you need to add self weight. Now click on add, then again close. Then again you need to add the floor weight. In floor weight, you basically need to add the dead load and the live load according to the seismic conditions. So dead load, how will you calculate the dead load? You can calculate the dead load with the density of concrete into the thickness of the slab you are taking. So we are taking here as in 6 inches, it's around 1.52 into 25. So after calculating this value, we'll get around 3.8 kilonewton per meter square. And these are the ranges which have been defined by structure wizard, as we have discussed earlier while making the model. So as our building is 3 plus 2, G+2, and I have defined our Y part around 10.5, I'm adding 10.51 just for the calculation point of view, nothing else. It's 10.5, and in x direction we have defined 20, so I'm considering it as 20.01. 20.01, it's barely having any difference. Just for sometimes starts don't pick some these values, and then we need to add these values, and further we need to go for live load. And for the live load, according to table 10 of IS 1893, we need to reduce the live load by 50%. As we are having a live load according to important building is around 5 kilonewton per meter square, but according to the clause we need to put here 2.5 as a 50% reduction of that, and the rest would be the same, the rest range would be same, and we need to add the same. See, we are having we have assigned the same. Now we have to move to load case detail. For having a load case detail, you first need to define the seismic horizontal along the x direction. Let's name it as EQX, and we need to add, and same second load case would be EQZ, add, then close, and then again we'll tap to EQX, add. We add the seismic load here. As we have defined EQX, the direction is in x direction, is already in x direction. We just need to add the same, and we need to close. Then we need to go to EQZ, we need to add, and again we need to go to seismic load. Now make sure we need to decide the direction as per we have defined EQZ. We'll click on Z direction, and we just simply click on add, and see both the things have been submitted there. Now we need to define dead load. So for dead load, we go to the load case detail, we add, again we go click on add, then we move to dead. We'll define it as DL, and we just simply add the same, and same applies for live load. We'll define it as live load, add, close. Now in dead load, we'll add salivate, we just click on add, and then we need to add floor load. In floor load, or value would be as same as the previous one, 3.8 the density into the thickness of slab. The range, this time make sure that we are applying minus sign because load is acting towards the negative y direction, and ranges would remain the same, like for y-axis it would be 10.51, for x-axis it would be 20.01, and for z-axis it would be 20.01 again. And we need to simply add this, and we need to close, and as there's a question mark sign, so firstly we need to assign the same to the model. We need to do the same for live load. Click on add floor load here, and as I have mentioned in the previous, that according to that particular clause we have reduced our live load from 5 to 2.5 as per the 50% reduction, but in this case we don't need to do the same, so we will use here 5 kilonewton per meter square for the as per the important building clause, and our ranges would be the same. 20.01, 20.01, and then we need to click on add, close, and we are done with our load case. But we need to apply load combinations here. So if you can see, the load combinations are there. We just need to tap on it, and we need to tap on automatic load combination, and we need to select table IS 456 and IS 800. Rest table 18 would be okay, and we need to generate loads. We need to make sure that we need to select the combinations which we actually need. These 0.9 loads are generally used when we are considering overturning situation. So we are removing these loads here, and I'm adding the load combination, and I'm closing the same. After the load combination, we just need to analyze our structure. We need to go to analyze command. Make sure we need to select all for the analysis command, and add and close the same. Then go to run analysis. Make sure to save the structure and see our output file. Go to the post processing mode. Yeah, in the post processing mode, move to the report section. In the report, go to setup report and then choose output. As we are concerned about the displacement, so we'll choose node displacement summary, and we'll move this particular thing here and click on OK. Once we apply OK, zoom into the section, and boom, we are having the results of this particular structure with zone 2 hard soil. And similarly, I have done all the rest zones with different soil types. In the end, the conclusion would be I have done with the hard soil of zone 2, medium soil of zone 2, then soft soil of zone 2, similarly with zone 3, zone 4, and also with zone 5. And the conclusion is it was found that for all seismic zones in G+2 building, same results for displacement were obtained for medium and soft soil. And second conclusion, I came to know that in all seismic zones, displacement were least in hard type of soil. So thank you for being a good listener.